Hi everyone, this is the fifth and final video for section 6.3 on multiplying and dividing fractions. So we are finally to the common algorithm, the standard algorithm, whatever you want to call it, the way that most of us know how to divide fractions. So we've talked about an algorithm for dividing fractions with common denominators, and that works. It all is fine. However, most people don't know that algorithm because we've just been taught the standard algorithm. So to divide two fractions, you don't ask why, you flip the second number and you multiply. So there's a ton of different mnemonic devices. A mnemonic is just kind of like a riddle or a saying or something like I just said. When dividing fractions, don't ask why, flip the second number and multiply. Jingles and things like that to help students remember information or algorithms or concepts or things of that nature. So that might be one that you've heard. There's a lot of different others. One that's really concise to talk about dividing fractions is a flip and switch, because to divide fractions, you keep this first number the same, but you switch the operation from division to multiplication. So you switch the operation and you flip the second fraction. So you rewrite this C over D as its reciprocal, D over C. So this is also called sometimes the flip and switch. Oh, sorry, that should be in black. So this is also sometimes called the flip and switch. So I'm sure you've heard some sort of mnemonic about this in your lifetime. And if not, I don't know where you went to school, because this is widely used. Mnemonics of this sort for concepts like this. So this is the flip and switch. Okay, so one thing about this algorithm is that it has no connection to any model or physical process of division. It is a trick that works. And if you want students to know truly what it means to divide fractions, this is not the first thing you should teach them. It's the last thing we're covering for division of fractions, and that's because all of the other things are showing you what's actually going on here, how we're actually grouping things and doing that repeated subtraction. So this is just based on the fact that dividing fractions, these two things happen to have the same result. And this algorithm, just something is to memorize. There's no model or intuition to fall back on other than these mnemonics. And that's why people have these mnemonics, is because this is not intuitive in any way. It's not like you can look at something and say, oh yeah, that's why we do this, because it has nothing physical to fall back on. We have all of these mnemonics to help us remember it, because all you have to do is memorize. Like, you have to memorize it for it to work. So we're going to do one example using this algorithm to show how we divide fractions. So whenever we do, we're only doing one example because this is the thing everybody does, and I'm also not the biggest fan of it. So when we do 3 over 4 divided by 1 over 2, we do the flip and switch. 3/4 stays the same. We switch the operation. We flip the fraction upside down, so we replace it with its reciprocal. And then to do multiplication, we multiply straight across. So we have 3 times 2 over 4 times 1, which is 6 over 4, which simplifies to 3 over 2, which we can rewrite it as 1.5 if you so choose. And that's all. All you do with this algorithm is you just manipulate the numbers in this certain way. Okay, so the very last thing we're going to talk about for this section, I know this is a very long section, we're going to talk about complex fractions. So a complex fraction is a fraction that contains at least one fraction or mixed number in its numerator or denominator. And so you can see an example of this down here in example 8, 1/2 over 1.5. So we just have fractions over fractions. So one thing to note whenever you're writing fractions over fractions, so these complex fractions of this form, if you write it like this, it's very hard to tell what's going on if all your fraction bars are the same size. However, if you write it like this, where you instead write this as 2 over 3 over 4 over 5, where the the major fraction bar is longer than the others, yeah, this is clear that this is 2 over 3 divided by 4 over 5. But if you just write everything as the same size, for example, if you're just looking at 2 over 3 over 4, well, is this equal to 2/3 divided by 4? Or is it equal to 2 divided by 3/4? Because those aren't going to give you the same answer. So make sure that you clearly distinguish either by writing things slanted like this or making one of the fraction bars a lot longer. Okay, so we're just going to do one quick example of how to evaluate a complex fraction. So we're going to look at 1/2 divided by 1.5. So to do this, all of our algorithms have dealt with most of our algorithms have only dealt with improper fractions. So I'm going to just change this into an improper fraction just for ease. So this is 3/2. And whenever we do this, whenever we switch this to the improper fraction of 3/2, then this is just the operation. This just represents the operation 1/2 divided by 3/2. And look, these have a common denominator. So we can use the common denominator algorithm. So this is 1/3 divided by 2 over 2. Well, I should probably write that intermediate step. This is just 1 divided by 3 over 2 divided by 2, which is 1/3 divided by 1, which is 1/3. So that's all you have to do for evaluating complex fractions is convert it to an improper fraction and then just do the fraction and then just do the division problem. And that's all you need to do to convert these. So like I said, that's all we're going to cover in section 6.3. So that is all for this video.